Okay, it's around time. It's 10 p.m. in Japan time, so I would like to get started. Hello everybody. So this is Junichiro Horikawa, and I'm going to do this weekly Houdini tutorial. And the topic for today is to create a bit a fun project, rather compared to other stuff that I've been doing, which is this kind of stuff, creating a small garden for a Pac-Man to run on together with these ghosts. And the fun thing about this is that you can change the geometry where the Pac-Man runs. So you can change the geometry to run on top of any kind of grid, like these, or you can even make it inward, running inside, like these. Or of course you can make it as a grid as well, which I don't really have a maze for this one, so everyone just moves on like every possible grid. But that's what I'm going to create today, and I'll show you how I created this one. And the logic under this one is pretty simple, but it might take a little bit of time to implement, so feel free to join or leave anytime. It might take some time to complete this one, but I think it's going to be pretty fun. So let me first explain how I came up with the algorithm. So first of all, it's easier to think from a grid like these. And first thing I'm going to do is it doesn't really have to be like a square grid, but any kind of like mesh is fine. And the first thing I'm gonna do is to create a network in which direction the Pac-Man can run through. Meaning in this case, I am going to connect the center of each primitive or each faces like a network like these. And this red line is actually the path for the Pac-Man or the ghost. Currently I didn't really make any interaction between ghosts and Pac-Man. It's just the difference of the variance, so it's not really interactable. It's not really like a game. It's just a installation kind of, but still fun. Okay, so after I have created the path like this for the Pac-Man pass, what I'm going to do next is to pick several starting points for the mover agent, which is going to be the Pac-Man. So let's say this point and this point and this point has been chosen, or maybe this point also has been chosen as an initial position for the Pac-Man or ghosts. Okay. Now, the next thing you want to do is to define in which direction does each of the Pac-Man would want to go on top of this red path. Okay. And the important thing is that for example, when this Pac-Man moves to this direction, then you cannot really move the one that's right here downward as well, because it's going to crash. Okay, which might be okay if it's a combination between Ghost and Pac-Man, but it's going to be really complex with those. I'm just going to apply a logic that whenever there is one agent going into a side, then this block has been blocked. This cell is going to be blocked for the next candidate for this one to move, for the other agent to move. So this one cannot go downward, but instead it has to go either left or top. Okay, same for these. This could go to, in this case, can go to anywhere. I mean, it can even go to the right side because this one, right agent, has just moved to the right side, so you have an empty space left. So this can actually go to the right side. Okay. And this same for these, it can go anywhere. So the key point is, how do we block, how do we prevent each agents to be crushed? Okay. And since we are going to make an animation, a procedural animation like the one that I just showed, I don't really want to use like a for loop for each point to decide each which direction should point go and counting one by one, because if there's tons of agents to calculate, then it's going to be a tons of calculation. So as much as possible, I want to use the multi-threaded calculations, like using point wrangle or primitive wrangle, like that. So to do that, first thing I'm going to do is to separate the cluster of agents based on the order and when these agents can move. For example, if the agents have at the same point, this point, this point, this point, and this point, with those paths. Okay. As I said, this one, and this one is close to each other, meaning we have to think about which ones goes first and which can go next. This one, I think it doesn't really need to care about because there's nothing in near. So first thing I would do is to pick the one that's free from the nearby agents as a first candidate. Okay, put it in the list as a first candidate. And I'm also going to pick one of the agents as a first candidate from here. And let's say I'm randomly going to pick this one right here. Then if I choose this one to be a candidate, then I think it's safer to prevent this one move at the same time. Okay, meaning if this one moves to the right hand side and then this one moves to the left hand side, this will obviously crash. So to prevent that this agents wouldn't crash with these one, think these block as an obstacle which this agent cannot move to. So keep this as a second candidate to move. Okay. Now after make this one as a second candidate, then we're going to check the other agents, which is this one, and see if this will be okay to move into this direction, this direction, and looking at the other first agent, and I think it's fine, so this can also be the first agent. Okay. Now that you have a first candidate for the agents to move, then after you have moved those agents, then you can go to the second one and keep doing it until you have all the agents to be moved. Okay, and I am going to repeat this one until each of the agents go to the next grid in specific frames, like 30 frames or so, like taking 1 second to move. And then for the next 30 seconds, I'm going to do the same thing over and over again. Try to estimate which one goes first, which one goes next, and which direction should each agent move. Okay, so that's the main key, main concept here. And most of the difficult algorithm that I'm going to implement is about this one, and all the other stuff is based on creating these like characters, funny characters, which is not that hard, I think. So let's do that. Let's try to create that logic from scratch. And I've just done it yesterday, and I don't really remember what I have written, so I'm going to look at the code that I have written previously to see, to follow what I have done. Okay, so let's see. And if you have found any questions, if you have any questions, please throw anything you would like. Alright, so first thing first, I am going to create a grid, which can be anything. I could start from 3-dimensional or 2-dimensional, but I think it'll be easier to start from a 2D grid, so let's just do a 2D grid. And later on, I'm going to make this enabled to be used as a 3-dimensional geometry to transfer from 2D to 3D. Okay. So after I have created this grid, the first thing I wanted to do is to first create a network. So this grid is the cell that each agent, in this case a Pac-Man, would move from to move to. And the path of the Pac-Man is going to be the center, the connection of the primitive from center to center of the primitive to the center of the primitive on the neighbors. So keep that in mind. Let's try to create that. And well, let's just see. Let's just try to create those, and I am going to create it. Let's see what will be the best way to do. Let me check. So so first thing first, I think using a point wrangle makes sense in this case. So let's try to do this. And there is some rule here. Let's check let's see that we are going to check at each point right here, there. And what I'm going to create is a square or triangle grid, a triangle shape for each point, except for the borders. Okay. For example, for these points, I can check the neighbor primitive for this point and create a square like these. And the edge of the square is going to be actually a path connecting the center of the primitive to the other center of the primitive. If I try to create the path, try to create a square at the border, then there's not enough points, which in this case there's only 2 points, 2 primitives from this point. So what I am going to do is to ignore all the points which is on the border and only creating these squares at the center, the interior points. So let's see. I am going to first first going to determine which one is the border point, okay, by using the group. Okay, I have a questions from Gediminas Kildeikis. Any UE5 video coming soon from you? Yeah, actually I did created some workflow to bring a animated geometry from Houdini to UE5 together with a custom attributes other than point, normal, or colors. So I think, yeah, I could make some video for that. Maybe later this week or weekend, if that's okay. Okay, so I'm first going to create a border group for the point, which is at the edge. I'm going to use this include by edge, unshared edges. Alright. Okay. Now, what I'm gonna do is to ignore these border group to create this square, okay, for each point. So I think I have to make this group previous to the point wrangle. Then for this one I'm going to say create path. Okay, now let's see. So first thing first, I am going to get the primitive the neighbor primitive, or the connected primitive to this point. And what I would like to do is to get this path in an order, either clockwise or counterclockwise, so that I can create a square from this point. To do that, I think the best way to do that is to first pick one of the half edge from this point, which can be either this one, this one, this one, or this one. Let's say I have picked this half edge. Okay, if I have picked the first half edge, then from this half edge I'll be able to get the primitive belongs to this half edge, which could be this one. And by getting this primitive, I can also get the next half edge belongs to the same primitive, which is this one. And then from that half edge I can get the equivalent half edge, which belongs to this primitive. And if you continuously doing that, you'll be able to get all the primitive in a clockwise order, counterclockwise order. I don't know which order it is by getting the half edge equivalent or half edge previous, but I think that by using those half edge logic, you'll be able to get the primitive in an order. Okay, so let's do that. First of all, I am going to check if the neighbor primitive count for each point is more than 2, because if it's less than 2, less or equals to 2, then you cannot create any primitive. You at least need to have 3 points in order to create a triangle or square. Okay, so let's get all the connected polygons first using point prims at pt num. Okay, then I'm going to check the length of the polygons if it's larger than 2, and that's the case where I want to create this square or triangle. It could also be used for the remeshed geometry where you only have triangles. Okay, so first thing first, I am going to get the half edge from the point. So I'm going to get the first half edge by just using the point h edge at ptnum, which will give you the first half edge belongs to this point. Okay, now from this half edge I can then get the this primitive belongs to this half edge. So let's get that. Prim is equal to h prim from this half edge number. Okay, now from this primitive, then I can get the next half edge. Let's say I have just retrieved this primitive from this half edge right here. So this is the source point of the half edge, this is the destination of point for the half edge, and this is the primitive. Now the next half edge value or index that I want is this edge right here, which belongs to the same primitive. Okay, now to do that I could actually, I think I don't really need to use the primitive itself, but I could directly use this half edge value by checking the previous half edge for this one, which is going to be if this one is the source and if this one is the destination and this is the primitive, then the previous half edge is going to be from this point to this point. okay, because the half edge always goes around one primitive from source to target, from source to target, from source to target, and from source to target. So if this is the source to target and this is the half edge, then the previous half edge should be this one going from source to target. Okay, so int a previous half edge is equal to edge previous prev 0 half edge. Okay. Then from this half edge, the one that I want to get is the half edge for this primitive, which is going from this point to this point. So you can get that by using a half edge next equivalent functions. So if currently I have the half edge going from this point to this point, but the one that I want next is from this point to this point, to the opposite direction. In order to get that, I can use the edge next equivalent from this prev edge. Okay. And now I have the next half edge. Okay. And by continuously doing it for all the primitive, you'll be able to get all the primitive numbers, and then you can also get the center point from the primitive to connect to create the square. So I do have a primitive right here, so let's also get the center point. Let's name this pos and get the center point from the primitive like this. Alright, now I am going to add this position as a new point using add point 0 position. Now this point has to be the vertex for this new square that I'm going to create. So let's also create the primitive. New prim is equal to add prim 0 poly. Then right after I have created the point, I'm going to use the add vertex to this primitive with this point number. And I think I have some errors here. I was missing the geo self. Okay. Now, okay, something looks wrong here. Let me just try to disable these one. Okay, so the problem here is that I have just done a first loop, I mean the first iterations, but I have to continuously doing the same things over and over again. And if you have 4 primitive, you have to continue doing this for 4 times. So let's also create the for loop somewhere after I have created the new primitive. So for int I until the number of neighbor primitive, oops, 0, lengths are polys. Okay, like this. And since I am referring to this half edge in the first line of the loop, I have to update this half edge and the last of the loop by using this next edge, by updating with this next edge that I have found out as a next half edge. Okay, now let me just save this somewhere so that I don't lose the process. Okay, now next, let's see what I need to do next. So I did get the half edge. Right now, let me also remove the primitive that I have just referred to, which I don't really need anymore, I think. So let's just do it inside a loop by using remove prim 0 prim num 1. No, not the prim num, but prim. Okay. Okay, I think I just lost all the geometry, so I think I'm missing something here. So let me see. Okay, first thing I was missing is that I need to ignore the border points, which I didn't really do that. So first of all, I'm going to create the filter right here. Okay, and now let's see. So I have just get the point primitives, and I'm checking if the number of the polygons connected to this point is more than 2. Let me just check if I'm getting the correct value right here. Please, and go to the geometry spreadsheet for each point. Now I should not delete anything in order to debug. So let's see. So I have this polys. Yeah, I do have values being created, so I think that's fine. Although not all the point is being used. Alright, let me just disable these one, which is creating a new points, and check with these. Okay, so seems correct, seems okay. I think these empty areas is just the one at the border. So I think these are okay, so let's go inside to check what's wrong here. So I have this point, half edge, getting the half edge, and I'm creating a new primitive, right? Now, and for each loop, for each polygons, for each neighbor polygons, I am getting the primitive first of all, primitive from the half edge, okay, then getting the position, which is the center of the primitive, then add that point as a, then add using add, okay, this is the problem here. This primitive is not the one that I've created, but this is the one that I've created, new prim. Okay, so make it right here. Okay, so something has just happened. So let's remove the original geometry to see what happened. Okay, looks pretty much the same, but the difference is that previously it was like these, and by using I've just created the squares which connects the center of the primitive like these. Okay, and which is going to be used as a path later on. Alright, so looks good, I think. Let's also set a group to these geometry just in case I can separate those later. So set prim group 0 path for this new prim as 1, right? Now let's fuse to merge all the connected points and then convert it into a line, because I am going to use it as a path for the Pac-Man to move. Alright. Okay, so the first thing I like to do now is to set some initial attribute to this path. For example, the one that I'm going to use, like, I'm gonna create a new attribute using attribute create. I'm gonna explain later how I'm going to use it, but the first attribute that I'm going to use is the current, starting from -1. Okay, so the current means it's the point which is currently used as the moving agent, which is either Ghost or Pac-Man. Okay, another one, which is going to be the next. So the next attribute is going to be the point number, where defines in which neighbor would the current ghost or Pac-Man would go. So if the Pac-Man is right here and this point number is the current point number, then for this next one, it's either this point number, this point number, this point number, or this point number, which defines the direction and which direction should this mover agent would go. Okay, that's the next. And can go num, which defines if the point can move or not, which would start from -1 as well. Okay. Okay, so these are the initial attributes. I'm not sure. I've done it like temporarily, so some of the attribute might not be necessary, but let's just say it's necessary. Yeah, I think it would work without these initial attributes, because if you don't have anything, then it will just create automatically. But let's just say these are the initials. Alright, now next thing I would like to do is to create a mover point, okay, which is going to be set as a Pac-Man or a ghost. Okay, so let's try to do that. I'm going to create a bunch of points on top of this path node, like getting 20% of the point, and then also out of those 20%, I'm going to set like 10% as a Pac-Man and other 90% as a ghost or something like that. Okay, so I'm going to use another point wrangle. Let's name this set init mover. Okay. Now, first of all, I am going to create a parameter which is going to be used as a percentage how much I want to use this grid point as an initial point position for the ghost or the Pac-Man to be appeared. So let's just name this threshold, or I don't know, appearance, or just gonna say thresh. Okay, and it's going to be from 0 to 1. If it's 1, then 100% of the point is going to be used. If it's 0, none of the point is going to be used. Okay, let's also create the null controller to have all the parameters that I would like to control later on. Alright. Okay, one question I would like to throw you guys, if you are interested in like connecting Houdini animation and Unreal 5 engine. Do you want the video to be recorded, or do you want the tutorial to be on live? Do you have any preference for that? If you have, please let me know. If not, I guess I would do the recording, I guess. Okay, so what was it? Appearance. Or mover ratio. Okay, from 0 to 1. Okay, so point 2. Let's start from point 2. Okay, so either way is okay, so then I'm going to think about you doing it on the recording, since in live it tends to take much more time than the recordings, because I don't have any way to edit it. Okay, so now that I have the threshold, let's do the random value for each of the point. So using rand at p, and maybe you also want to have some random seed as well. It's less than the threshold. Then you want to create a point, okay, which is going to be used as the mover. So int add point. I'm just going to create a mover point at the same point position, the same node point position. Now, first of all, I am going to set the group so that I can define that this is a mover group. Okay, at pt. Okay, I think I have some errors here. The resh. If, okay, I have to close the randomness. Alright. Now let's just see if this has created the point or not. I'm going to try to color, or maybe use the copy to point to check if the mover point has been created. And I'm just going to copy this to the mover target. Okay, so that's the number of mover that I've just created, which looks good. So let's continue with these. Now, I'm also going to create another random ratio, which is going to define, which is going to separate the mover between the Pac-Man and the ghost, which is not like critical stuff, but just for fun. So another randomness using at p plus some other value plus the same seed value, which should create a different value, and smaller than maybe another threshold, which in this case, I don't know, Pac-Man ratio. Pac-Man ratio. Okay, and I'm gonna make this 0.2. It should be here as well. Okay, well, also since UE5 is in alpha, I assume it's a bit unstable. You don't want it to crash on you during the live stream. Exactly. Yep. It didn't really crash at this moment when I have tried. Actually, Houdini crashes more than Unreal 5. But like you said, it's unstable, still unstable, and the rendering for the unstable topology is not that great. So yet. So probably those stuff is going to be much better in later. But still, I'm gonna show you some process which could be pretty useful. Okay, so what was the name? Pac-Man ratio. Okay, from 0 to 1. Let's make this 0.2 as well. Oops, copy parameter. Right, now for those point which is less than 20%, let's set it as let's set the variant attribute, which later on I'm going to use it with the point copy to point group sop node, which is this one. So set point attrib as variant to this pt as 0. So 0 is the Pac-Man. Now else I'm going to set it as variant as 1, which is going to be used as a ghost. Okay. Now let's see. And the next thing I would like to do is to set the the network node where the agent has been spawned as the current node or current attribute, or I mean the current node. So, and this current node is going to be the number of this mover point, okay, which is this one that I've just created. So set point attriv 0 current to no actually what I'm trying to do is to copy the current point number from the node to the mover. So the mover have all the attributes, the current, next, and what was it next? Current, next, and can't go num, can go num, and so on. Okay, so I am going to copy the current point number from the node to the mover point. So I should write like this. Right. Now, in this case, I am working with 2D grid, so it's not really necessary, but just in case I'm going to transfer, think about how that I am going to transfer this into a 3D later on. I'm going to try to get the normal direction of this plane as well and set it to a mover point. So to get the normal direction, I can go back to the original geometry somewhere around here, maybe this one right here. And since I'm going to create the initial geometry like a grid, so probably the resolutions of the geometry is not that high, so just in case I am going to subdivide this geometry a little bit to make it a bit smoother. 1 or 2, maybe 1 is okay, and then calculate the normal for each point because I want to sample the normal direction from this point. Now connect it to the initial mover, init mover, go back, then get the normal direction from the second input by sampling using the UV. Okay, so what I'm gonna do, vector norm is equal to UV sample from the second input, normal direction, using a P as a UV value. Okay, by doing this one, you'll be able to get the normal direction from the second input. Then I am going to apply this to a mover as an attribute. So set attribute, set point attribute, set the normal direction for the mover point with this normal direction. Okay. What else? Now I would also want to create the initial direction where this mover would want to go for, probably. Or do I need that? Let me think. I might not. Yeah, I don't think I do need that. Yeah, let's just leave that. Okay, so this is the initial setup. Okay, I have a comments. UE5 would be awesome. This is asking a lot. Both maybe do the recording later after allowing us some time to follow the video and try it out. Do a live exploration of your creation with Q&A. Yeah, if that's necessary, I could also do that probably, but the thing that I'm gonna show is not that hard to follow, I think. I mean, there is 3 ways, I mean mainly 3 ways to achieve it. If you already know some technical terms, I can just say it right now. First of all, the first thing is to use the alembic, and instead of using the color attribute, you can just change it to the other attributes. But the problem is that it's only limited with one attribute, so cannot really do much more than that. Another way is to use the VAT using vertex animation textures, and there's a component for the Houdini called from the side effects labs, which you can export the vertex texture animations, or vertex animation textures, which in default you can only export the position, color, and normal maps, I think. But by tweaking a little bit, by hacking it a little bit, you can export like as much attribute as you want as a texture and use it as a inside a shader as an additional attribute. So that's the main part. Now the last part is a bit more hacky, since I found out that some of the geometry, especially if you use the side effects labs VAT component or node, there is still a bit of problem when you want to create like a fluid shape, non-topological shape, non-topological stable shape. The rendering looks a bit messy. If the number of the vertex is the same overall, the time frame, then you can use the soft setup, which you can create a really clean animation. But the problem is with the fluid, it doesn't really create a clean animation. So instead of that, I am trying to create another method for myself, which might be too hard for everyone to follow. But for that, I'm trying to combine both alembic, which creates the smooth geometry, as well as the additional like texture to use it as a vertex animation texture. So combining alembic together with the VAT, that's the third option, which might be too like hacky and not too friendly for anyone, but should create a bit more better result. But I'm thinking to show you the second option. Try to hack a little bit the VAT and to be able to use many attributes as possible. Okay. So that's that. So if you have any technical like imagination how it works, maybe you can just do it by yourself from what I have just said. Right. Okay. So did you try using HDAs in Houdini engine with Unreal yet? No, actually not. I haven't used the Houdini engine for Unreal. I have used it for Unity. I have checked if I can use the Houdini engine for the animation, but it seems a bit too tricky, so I haven't really touched yet, because I wanted to bring the procedural animation. But it did look cool that you can do the modeling inside a game engine. But unfortunately, the engine cannot be shipped when compiled, so it only works on the editor. So that's the kind of a downside, I guess. Okay, so where was I? So I have just copied the normal to the mover attribute. Now the next thing I would like to do, so this is done. The next thing I am going to do. Okay, so the initial setup is done, so I'm going to get inside the solver to actually create some animation. Okay, so this one goes to the first input, and for the second input, I think I will need this base geometry to copy the normal direction again for the mover. If it's 2D, then it doesn't really matter. because the normal direction is always facing up. But if when it gets to 3D, this geometry is going to be important. So that's that. Let's go inside and let's try to create this procedural animation. Alright. So first thing first, I am going to create several switches when does some operation happens and when does the specific operation not happen. So there is mainly 3 steps that I need to do. Okay, first of all, for each like 30 frame or 15 frames, the frames you specified, like maybe the if you're starting from the first frame, the frame 1, then for every 15 frames you want to move the mover from the first point to the next point and spend 15 frames to do that. Then for each 15 frames, in this case 1, 16, 31 and 46 and so on, I need to recalculate which direction should point go from the current point. If the current mover point is right here, then you have to decide which which direction should mover go. And as I said, if there is multiple points blocking to each other, then I have to decide which collection of the points should go, decide first where in direction where they can go, then pick the second group so that they can decide where they should go next, then pick the third and so on, using a loop to decide. Okay, so that's what I would like to do, and the timing that I need to do those calculation should be every at any time the point has come to the first point or the edge of the point or on top of this node. Okay, so let's say every 20 frame for now. I'm going to create a switch and let's create some expression. If the current frame modulus 20. Now this 20 should be better if it's being parameterized, so I'm going to go back to the controller, create a frame parameter like moving step or moving step frame. Okay, from 1 to 50. Okay, as initial value, I'm going to set it as 20. Copy this one, go back inside, paste it right here. And if it's equal to 1, then that's the timing we want to run the initialization code to decide which direction should point go. Okay, so let's connect this right here. Okay, now if it's 0, then if this value is 0, meaning if it's 2, 3, 4, 5 until 20, from 2 to 20, I would like the point to just move, which the point should be on top of this edge, moving from left to right or right to left, bottom to top, and so on. When it is equal to 1, then that's the timing where the point has come to the end, right here or right here, and on top of this node. Okay, so when the point has come on top of the node, then I have to decide which direction the point should move to. So let's do that. And to do that, as I said, if you have a multiple number of mover agents, I have to collect a bunch of points together to pick the first candidate, second candidate to decide its direction. So I'm going to use the for each loop using a number. Okay, and probably creating as a feedback loop makes sense. So make it feedback each iterations, fetch feedback, connect it right here, connect it back to right here. Okay, so currently it's a bit hard to see which one is the mover point, so let me just colorize those mover point. So I'm going to use the color node and set it as yellow. It's a bit hard to see, is it? Is there any point? Let me check. Yeah, there are. I cannot really just see it. Let me scale up a point size a little bit. Right. Now I can see it. So I guess these points are the one that I'm looking for. Is it? Yeah. Maybe yellow is a bit too hard to see. Make it red. Okay. Now going back inside the solver. First I'm going to connect with the null node. Later on I'm going to use it to decide when to stop this for each loop, because you don't know how much loop you want to do this one. Okay, so let me just name this stop. And later on I'm going to check the detail attribute from this null node to see if the loop can be stopped or not. For now, let's just ignore this. Okay, no. Now, the first thing I would like to do here is to check all the points and see if the point can see if this current point can go or move next as a candidate. Okay, so for example, if I look at these points right here, you see that there is a bunch of neighboring points. Now I'm going to randomly, I'm going to just use a point wrangle, meaning I'm going to simultaneously check whether the point can move. And you may ask if it's how is it possible to check if the point can be moved when you try to calculate the direction simultaneously? Well, I'm not going to calculate the direction at this point. I'm just going to check if the point that I'm going to use, I'm just going to pick the point as the first candidate to move. Okay. To do that, I'm going to for each of the point, I'm going to pick the point positions and also get the neighboring point. And if there is a neighbor from this point, let's say I'm looking at this point, and if there's a neighbor point from this point, then I'm going to check the point number, okay, smaller or bigger, okay, and I am only going to pick, only going to set the set it as a candidate when the point number is either smaller or bigger. Maybe let's say if this point number is smaller, then those point is going to be used as the next candidate. And if you do it if you are focusing at this point, and let's say this point number is smaller than this one, then the result of this comparison will be the same even if you are focusing with this point, because the point number doesn't really change. So this point number is always smaller, this point number is always larger, so even if you do the same process for this point, you do get the same result. And this one always be used as the first candidate. Okay, so that's kind of that's is the logic right here in order to choose which candidate will be used for the next move. Then these point, maybe this point, or this point will be picked. Now, one more conditions I guess I need to refer to. For this point, this point is obviously a point where you need to check, but this point is also the one that you also need to check, because if this comes to right here and if this one goes to right here, then this will crash to each other. So these point are all the candidate. I mean, from this point you have these neighbor, you have this point, and this point as a neighbor, and from each of the neighbor points you also want to check the next neighbors from this point. And those second neighbors are also the point you want to compare with, whether the point number is smaller or larger. So if there are any mover points, if you're focusing on this one, and if there are any mover points at this point, this, and this one, then you want to compare all the numbers, all the point numbers, if it's smaller or not larger. And if this one is the least smallest number among all the neighbor points, then this can be chosen as a candidate. Okay, so that's the basic logic, which one to choose for the next go. Then if you have chosen the candidate, then you can just move it randomly to one of the directions. Then on the next loop, you can then ignore the candidate which has already been used, and then go to the remain points to do the same calculations. Okay, so that's the main logic, and that's the hardest one to among this sketch. But it's pretty useful idea, I think, for many other purposes. I think when you want to deal with as many points as much as possible, even if you think you can only do it recursively one point at a time, but by doing like this, you'll be able to pick a collection of a cluster of points altogether to process simultaneously as much as possible. Makes the performance better. Alright, so find, let me name this find and go. Okay, and okay, so I think I have forgotten one thing. I haven't set any groups for the points that I've created as this path. So let me go back to apply that group. Let me leave the solver and let's see where I have set it. I think I can set it. Let me see. Let me check what I have done previously, because I don't want to miss it. Okay, where is it? Actually, it seems like it's inside the solver. Okay. Well, I think I was talking about the one that I have. Wait a minute. Let me check what I did previously. Okay. Okay, I think, well, let me just try to I think this one is checking whether I can go or not, but the one that I have to do initially is to decide let me go back to the original stuff that I did, see what I was doing previously. So I have this okay, I forgot to set one group called agent okay, for all the grid point. So let me do that first. The agent in here will be applied to the node point, those points on the path, and the initial agent group should be applied to the node where the mover is standing on. So those red points position is the one that I'm going to apply the agent group. So going back to the init mover, I'm going to create another code set point group to and named as agent at ptnum as 1. Okay, so to be able to see which node has been applied as an agent, I'm going to create another color node to check for agent. I'm going to set it as dark red. Alright, so these gradient node are the one that I've just applied the agent node, the agent group. Okay, so going back now, I am only going to, what I'm going to do now is to look for the agent group so that I can refer to the neighbors. I can also refer to the mover, but the mover is not really connected to any like node, so it might be, I thought it will be easier to check the neighbors by checking the agent node instead, which is on the path. So that's kind of a reason. But you can do the same thing by choosing the mover group as well if you want. You might need a little bit of referring to the original path from the mover group based on the position. But I don't want to do that, so I'm gonna just refer to the agent group. Alright, so let me first get all the neighbors from the current point. So int npts, I'm gonna say npts1 because I'm going to get 2 neighbors. One neighbor from this current point and another neighbor from the neighbor of the neighbor. Okay, so you need 2 recursive neighbors. So first neighbor, and for each neighbor I'm going to create a loop. Let's bring up the editor. Name this mpt1, and I am going to check if the neighbor point is actually a agent or not, meaning from this point I'm going to check all the neighbors and see if it's agent, meaning red. Okay, so I'm going to check it by creating an attribute or variable called eng1, check using in point group agent at the neighbor point, and if it's agent, then I have to compare those two numbers, which one is the smaller point, and I'm going to use the smaller one, right? So if the eng1 is equal to 1, meaning I have found out the neighbor point to be an agent, and also let's say I'm just going to check if it's in agent, then I'm going to compare the neighbor point and the current point number. Then if the neighbor point is smaller, which means this neighbor point is smaller, then I'll just leave all the process, because I only want to apply the attribute when the point number is smaller, when the current point number is smaller. Okay. So, and I think I also need to stop the process when this point that I have found out, which might not be agent, but which is already been taken by other agent from previous candidate, then that grid, that point cannot be used as well. I haven't really created that value yet, but I'm going to name it as a go group. Okay. So I'm going to assume that I have this go group to each of the point as well, and which indicates that this point can be used, can be set it as a go-to point or not. If it's equal to 0, then which means it's already been taken, you cannot really go there. So int go1 is equal to endpoint group go at npt1, and I'm gonna check if the agent or int group, the agent is already being used, and the go1 is equal to 0. I'm not sure if it was okay with the and. It might be or forgot. Let's just go with and I'm gonna go back later to, maybe I might need to fix this one later. Okay, now the second loop for the getting the neighbor, second neighbors. So npt s2 is equal to near points neighbors, which is pretty much the same as this one. And instead of using the current point number, I'm going to use this npt1 right here. Okay, and doing another loop, which is similar to this one. And I should not use variable I, but instead something else. Alright, and this one has to be 2 as well. Okay. Now, I'm also going to check if this neighboring point is used as an agent or already being chosen as a go group. So I'm going to do the same thing. Wait a minute. I think the go group has been set for each agent, whether the agent has been moved or not, wasn't it? I think so. So if it has been moved, then you can actually you can actually go to that direction, so you can kind of ignore it. So I guess this is correct. Checking if the agent is equal to 1 and if the agent has already been moved or not. If it has been already, if it hasn't been moved, then the agent is at this point right now, so which means you cannot really go there, so you need to end the process. Okay, so I think this is all right. So I'm going to check the agent group and the go group for the second neighbor. Do the same conditional check these. One, go to bt1, and this one should be okay with pt_num because you are only you are comparing with the current point number. Okay, and you only want to operate to this point number if the point number compared to all the other agent, neighbor agent, is smaller, if this one is smaller. Okay, so if you could go further, then that means the point number is the smallest. Then I can set some group here, and that is the one called go, which means the point has been chosen as a candidate to move. All right. And since this go group is going to be left out as a cache for all the loop, for each feedback loop, I also need to have another group set to the same point, which is only going to be used at the current loop, current iterations in the loop, to actually move the point, to decide the next point position. So I'm going to name it as current go. Okay. Forget to say 1. Alright. Now I think I need one more conditions here in order to stop the process, which is if the current point number has already been chosen as go, which means you don't really need to pick it as a next like candidate anymore. So maybe I can do that somewhere right here. If in point group go for the current point number, if the point number has already been chosen as a candidate, then I don't really need to do any process for this point, so just return it. Okay, I think that's it. Now, by doing this one, you should be able to see some groups being chosen for some of the point as a code. Now, to check that, I'm going to limit the number of iterations to 1 so that it's a bit easier to see what's going on here. Okay, now let's see. I'm going to check which agent point has been chosen as a next go, the first candidate. Now let me check whether I have this go group right here, and I can see that some of the point has been chosen as a go, which is among this agent group. Okay, now let's try to color these different. Okay, so I am going to set the go and maybe color it to blue to see which one has been chosen. Okay, it's a bit hard to see, but you can see the kind of a gradient point underneath this red point. It's a bit hard to see. Maybe I can make it yellow probably. So I can see that these point, which doesn't really have any close neighbors, has been chosen as the next candidate. These one. Now this one and this one is close to each other, and this one has been chosen instead of this one because the point number for this one is smaller. This one doesn't have any neighbors, so this one has just been chosen. Now these one, comparing all those in these clusters, this one has the least point number, so I guess this one has been chosen as the next candidate, and this one has been passed for the next iterations. Okay, so this looks good. Now in the next iterations, what I want to do is to choose from the agent which haven't set it as go group to decide it as a next candidate. But before doing that, we also we need to check each of these go group to decide which direction should point go to. In this case, the neighbor point number from this point, either this point, or this point, from this point, or this point, and so on. So let's do that. I am going to use another point wrangle. Okay. And I am going to name this choose the next agent point number. Okay. And I'm only going to apply this to the one that has this current go, which is the group that I applied previously to those point that I have chosen as a candidate. And this current go is only going to be used inside this each iteration, and it's going to be reset at every iterations, I think. Was it? I think so. Right, so let's do that. So first of all, I'm going to get the neighbor point numbers from those points that have been chosen and randomly pick the direction using some random value. So I'm also going to refer to the iteration numbers so that I can create a random seed value based on the iteration numbers. So int iterations from the detail, get the iteration number, and also get the neighbor point numbers using the neighbors at pt num. And I'm going to loop through all the points inside the neighbors. Okay, get the neighbor point. Alright, and let's check if the candidate point is being used as an agent or not. I mean, there is a chance that it's being used as agent, like this one. If you found out this neighbor has already been chosen as an agent, then you don't want to go to this way. So instead, you want to go either this way or this way. So let's say if in point agent point group 0 agent at the neighbor is equal to 0, and you also want to check if it has been chosen as the next agent, which means I'm going to do it inside this wrangle, but after I have decided which way to go, I'm going to apply the next agent group to that point. Okay, so that point is going to be reserved for the point to move to, so you don't want to move other point to go to that point. So I need to check whether the point has already been chosen as a next agent group. So in point group next agent neighbor is also equal to 0, then you can finally go choose that direction. Okay, now instead of just trying to pick the point randomly directly, I'm going to first create an array which contains all the possible points or point numbers where this this agent point or mover point can go to. In this case, this point and this point. I'm first going to create a list which contains all these two points. Then from those 2-point array, I'm going to use the random to pick one of the point numbers. So I'm going to name as candidates as an array, integer array. Then append inside the candidates the neighbor point number. Alright, now after having all these array being created, I can now use some random values to pick one of the point. Okay, so let's do that. I'm going to create the random values int rand index is equal to random, maybe a point number plus or multiplied by some values plus some seed value plus an iteration related value. Okay, this will be enough. And then I need to make it as an index. Currently I have just created the value in between 0 to 1 as a float value. So it has to be the multiplication of the lengths of the candidates. And then make it integer by using a floor function. Alright, now this will be the random index. Now let's let's pick that point. Now before going into that, I might need to remove some of the point number from the candidate as well, which is which in this case, if there are there's more than one candidates left, and if well, let's just ignore it for now. I'm going to just pick up random points for using this rand index. So the candidate number is cand is equal to candidates at rand index. Okay. Now that I have picked up one of the point, I can now set a necessary group information to that point. So set point group 0 next. So I'm going to set the, wait a minute, not next, but next agent to this candidate point as 1. Alright. And for as a point attribute to the current node, I can then set the point number in which direction should the agent or should the mover on top of this point should go to. So in this case, if I have chosen this point, then I am going to store the point number of this one inside on top of this node point. So, which looks confusing, but set point attriv 0 next at npt with the candidate number, which is going to be useful later on. Okay, this should not be npt, but ptnum, the current point number. Alright, now I would like to do the same thing for the mover. I want the mover point to have the same information, this next point information, which could be useful. So I'm going to pick I'm going to search for the mover point, which should be on top of this agent node. So I can just search for it by using the new point, filtering the mover group at P. Then as soon as I found it, I'm going to set point group attriv 0 next pt candidate. Alright. Now there is a chance that the point within those agents, well, I mean, I think having an agent means that there is always a mover, so I think this should work. Okay. So other than that, I can now reset the current point to have current go to be 0, and just keep the go group as a cache to use it later on to check. Okay, but the current go, I don't really need the current go group anymore, because this is to decide which point should move. And after I have decided, it's not really necessary, so I'm going to remove that by using set point group 0 current go ptnum to 0. Right. Okay, so is this enough? I think I still need to write something, but let's just ignore it for now and go to the next one. I'm going to come back later. Okay, now I also need to have an information when to stop this feedback loop. The feedback loop is the purpose of the feedback loop is to choose all the points as a candidate to move or not move. So when all the agent node color becomes yellow, in this case, all the agent have the go group, then that's the timing when you want to stop the loop. So let's create that information using attribute wrangle next or count. So what I need to do is to count up all those points which doesn't have a go group yet. Okay, so I can just count the number of agents and number of go groups, and if you subtract those two numbers and if the value is not 0, then you still need to loop through. You still need to do the looping to fill all the points as a candidate. So let's get that. First of all goes the number of points inside a specific group, endpoints group at inside a go, and the agents is endpoints group 0 agent. Okay, now I'm going to calculate the subtraction. So I'm going to create a detail attribute called canGoNum is equal to agents minus goes. And I have actually created this one somewhere, which is in outside the solver at this attribute create. And okay, I think I needed to make it as a detail attribute instead of the point attribute. So let's make this detail. Check this one. Go to the details. I have this can go num. Can go. Okay, spell mistake. Can go num. Okay. And has to be an integer. Alright. What's the other one? I think I also need to make the other ones to be an integer. This one. And this one as well. Current and the next. Okay. Okay, so all is good. Going back. And let's see if I have this can go num right here and this one right here. Okay, so I have just updated this can go num detail attribute by calculating the subtraction between the number of agents and the goals. And this should be either positive or 0. If it's 0, then there's no more. Every point has been chosen as a candidate. If not, if it's positive value more than 1, then more than or equal to 1, then you still need to loop through. Now, if I look at this one, let me just connect this one. I look at this point and check the detail attribute. It says can go num is -1, so I think something is wrong. Okay, endpoints group 0 go, endpoints group agents. Okay, let me first check if those values are correct. Okay, I add agents. Something must be wrong. Okay, nothing has been changed. That is because I didn't change this to detail. That's it. Okay, so I do have these numbers. Let's see. So currently the can go num is equal to 4, so I have 4 points left. These point and wait a minute. Okay, so these 4 points or 5 points, is it? Looks like 5 points. Just say 4. Not sure why. Well, oh, inside this loop it become 4. So I guess it's already been looping. So I guess that's the reason. Okay, so so what I want to do next is to stop the loop when this can go num detail attribute becomes 0. And to do that, I'm going to refer to this first node inside the loop, the detail expression for this for each end. So at this stop condition, I'm going to check the detail attribute at stop and can go num, and if it's equal to 0, then that's the timing you want to stop. Okay, now let's see if I raise this value up. You can see that the candidates is being filled with the yellow color, and at some point the loop ends right here. So at this point it took around 6 loops to fill all the points. Okay, seems to work fine. Now, and the next thing I want to check is in which direction each of the point is trying to go. So I am going to draw it with a color node, I guess, after leaving all the loop. I'm going to set the loop as point. Does this have a point group? Should be. So I'm going to color up this current go, which has been chosen as a go, but doesn't seem to have any values here. Okay, am I missing something? Let's see. Let me see. So I have this current go, nothing. I do have this go. Oh yeah, actually I don't really need to color the current go, but because it's only temporal value, so it's not really necessary. What I need to draw is the next agent. Which agent has been chosen? So which is this one? Okay, so let's see. Using the color node, I am going to use the next agent. Maybe set it as a green. Okay. It seems like some of the point which is going to set these point has also been chosen as the next agent, and I'm not sure if that's the right direction. Not sure, but let's check out. Okay, so next. So this is pretty much the initial process, and then by using those information, I'm going to try to then finally move the mover point using those informations, which is applied to the node and both to the mover point. Okay, so I am going to use the point wrangle to work it only for the mover point, which is used as a Pac-Man. Okay, and first thing first, I'm going to define like how many steps I want to use in order to move from one point to another, and that value has been defined right here. So I'm going to copy these expression, checking the channel from the controller null node. I'm going to name it as frame. And paste that value right here so that I can use it inside of X. Alright. Now, float t. First I'm going to create a value code t based on the frame value. So for every 15, in this case every 20 frames, I would like to create a value in between 0 to 20. I mean 0 to 1. Which will be easier to use. So to do that, first I'm going to get the current frame, then calculate the modulus, the remains with the step frame, or just the frame. Then you'll be able to have a value in between 0 to 19 in this case. Now I'm going to divide it by a number of total step frame, which is 20. So in that case, you'll be able to have a value in between 0 to 0.99 or something. Okay, so step frame. Or actually, what you get is, since it starts from 1, so what you get is actually a value in between 0.01 or something, 0 point some small value to 1. Okay. And I also want to make sure that if t is equal to 0, meaning the modulus, the calculation modulus becomes 0, meaning when the frame is equal to 20 or 40 or 60, I want to make sure that the t is forcefully set to 1.0, so that because t equals 0 and t equals 1 in this case will be used similarly. In this case, I'm going to use it as a position value, and it's a bit having 0 for t is a bit difficult to deal with in these situations, because you need to have, if it's 0, then you might, the point position of this mover might jump from one to another, from previous point to the next point by having this 0 value. So I'm going to reset to 1. Now that I have these value, I can now get the current number from the current mover point, which I haven't really applied to it yet, so I have to do it somewhere else. But I am going to get the point positions, which is on the node, getting from the current attribute, and also get the next point position from the next attribute. Now I do already have this next attribute inside a mover point, but I don't really have this current point, so let's create that. To do that, let's go back outside the solver, and if I have done it previously, and I think I do need to create it previously for the initial current value, which should be as soon as I have created the mover point. And I actually did have this current number set as a current point number to the mover. Now that is good, but after going through the first step frame, I need to update this current number somewhere. So that should be right before you search for the next point. So maybe somewhere around here. Okay. But those initial conditions to search for the current point must not be called when the current frame is equal to 1, because you have already set the initial values right here for the initial setup. So except for the first frame, I want to do the initial resetting for all the attributes, like the current number and so on, and all the other related groups. So I do need another switch here to ignore only the first frame. When the first frame is equal to 1, then I just want to skip the whole process to go to this one. If not, then I can do the initial or the reset setup right here. So let's do that. I am going to go inside the solver and let's see what kind of stuff I need to do. So first of all, I'm going to create the attribute create to reset some of the attribute values. Attribute create. Okay, has to be something like this. Now, the thing that I want to do is to reset the detail attribute, which is called can go num, to -1 at each 20 frame or so step frame. Essentially, I need to do all the stuff that I did somewhere around here inside, right here. So I have reset the can go num to -1, and I also would like to delete some of the attribute or the group that has been created, which is inside here, which is delete group delete, which is, first of all, go. Let's set it to point group, and I also want to delete the current go as well. And I also need to recreate the agent group, and I don't really need the previous agent group, so I can also delete the current agent group. Alright, now let's recreate the agent group and also the next agent to be set it as 0. Probably I can delete the next agent right here as well. Okay. Then, oh, actually not, because the next the agent group has to be applied to the next agent group, so I cannot delete the next agent group right here at this point, but instead I'm going to use the point wrangle filtering the next agent and set point group 0 agent, set it to a agent group, meaning transferring from next agent to the agent. Now after I have transferred the group, then I no longer need this group anymore, so I can group delete this next agent. So next agent. Okay. What else? Now, I think it's also a good idea to have the previous point number and can be used as information define in which direction the point has come from, which can be used to check which point should be blocked to go. So I'm going to create that previous point number value for the mover and copy it from the current at this point, since the current attribute is going to be updated right here inside. So the previous one is going to be used as the previous one. Alright, rev. So I guess this is pretty much it for the resetting stuff, I think. Now let's connect this back to right here. So make sure that this one, wait a minute, this condition is not good. If f is if f is larger than the current frame is larger than 1, then you can run this one. So I have to switch this one right here. This goes to the right. So in the first frame, this does not run. But after the first frame, then every 20 frame, this will start to run to reset the information. Okay, now going back to some of the code inside a for loop again, I probably need to use this previous point number information somewhere. Let's see, where was that? Okay, so I think that was inside this next agent, where I have decided which agent be used as the next candidate. And so this is where I have chosen the candidate, or not. Maybe previous to. So after I have chosen all the candidates and stored it into the array, what I want to do next is to get the point number of the move and also get the previous point number, which also means the current point number copied to the previous right here. And if the candidates include that previous number, then that is going to be a problem, because these points might not move, so you might have a crush between the point which is in so I think these are the point which has these problems right here. So let's make the condition here. If the length of the candidates is more than 1, okay, and I want to check, or it could be 0. And I want to check the closest moving point. So npt near point 0 mover at point position. Then get the previous point number from that mover point, which is derived from the current point number. And if this candidate has this number, then you don't want to move to that point. So I am going to remove that by using the remove value from the candidates. This might need to be 0. Yeah. More than 0, I think. Okay, and there is a chance that the candidate becomes 0 length, meaning you have nowhere to go anymore. Okay, so in that case, in that case you can just stop at the current point position, meaning the initial candidate numbers to be a ptnum. But if you found out that the length of the candidate is still more than 0, meaning you have at least one item, then you can choose one of the point number from the candidates and update it, so that it doesn't have to stop at the current point position. Okay, I think it makes sense, probably. And if I leave this loop, not sure if it's working by the color. Let's try to see it in animation. Okay, so going back to the point wrangler right here, I'm going to name this as moving. Okay, now that I have all the necessary informations to calculate the movement, it's time to actually write the fun part in order to move the point from one point to another. And I already have the necessary informations, which is the from point position to the next point position. And then I also have this t value, so lerping those positions with this t, I'll be able to get the current point position. So vector new pos is equal to lerp from current point position to the next point position using t. Right. Now update the point position of the mover with this new position, and that's probably it. Now if you want to make it as a three-dimensional stuff, then I also would need to apply some normal direction for the mover as well as the up vector. Okay, so let's also do that. I'm going to reference the geometry coming from the second input, which is this original surface right here, which have the normal direction at each point. Now let's sample those normal direction using UV sample from second input and using P as a UV value, current P as an actual value. Okay, now now that I have this normal direction, I can now try to set the normal direction with this sampled value, and I could also set the up vector, which I don't really have it right now, I think. So let's just ignore this for now. I'm just going to apply this normal direction for now. Okay. The point has just been moved a little bit because it's at 1. Now let's see if it's going to move as I supposed. So you can see that the yellow point is the current point number and the green one is the candidate, the next point position where the point is trying to move to. As soon as this point comes to this node, then the new next agent or next candidate is going to be chosen. Oops. Okay, something bad happened. Okay, I can see that something weird is happening. I can see that the yellow color is increasing, which is not really a problem because I have to reset the color actually. So let's do that somewhere around here. Color, but the movement, the area with the movement, I think I need to fix somewhere. So let's see what is wrong. Okay, so let's set the all the point colors to white initially, and okay, let's see what is wrong with these one. Let me just color the mover with the red so that I can see it better. Okay, mover. Am I seeing it? Okay. Now, initially, okay. Probably I shouldn't reset the color right here, but I should reset the color somewhere around here. Okay, that should be good. Now let me check. So as soon as it goes to the next point, it goes back to the original positions, so that's one problem. So let's see why. Which means as soon as it comes here, the current point position has not been resetted. So I think I'm missing some reset function somewhere. So let's see where that is. Okay, so let me check the attribute. Going back to the geometry spreadsheet I'm only going to check the mover agent, mover group, which is these one. Okay. So since I'm going to check the number of the group, let's say I'm going to focus on this one. Let's set 86. So 86, this one right here. Okay. Now this is a group. And I have this next number and the current number. Now I can see that it's going from 18 to 19, which is correct at this moment, 18 to 19. And does this have a previous value? Not yet, because this is the first frame. Okay, now if I go to right here, how does this change? Okay, as soon as it becomes 21st frame, then the current became 18 back again, so current didn't really change, so that's the problem. And the next one seems to be correct, so I need to fix that. I need to update this current number as soon as it becomes the 21st frame. Okay, I think I missed that. So going back and see where I should do that. Okay, so let me check what I have done previously. Should be inside either this one or this one. I'm thinking it should be somewhere in here. Probably I was missing one node to do that. Okay, so I am going to add additional point group, which only look at the mover group. So to update the current point number, so point wrangle init mover and int only look at the mover. And what I want to do is to, after I have moved the point, after I have moved the mover point to the other node, the other end of the node, I need to get that point number from this node, in this case 19. So to do that, I'm going to search for the nearest point from the agent group. From the current move position, then update the current with this found point number, which is set as an agent. Now hopefully this will work, and I also need to I also forgot to reset the previous number as well. So let's also do that. The previous number is only used inside this for loop, so I think I can reset it as soon as I have left out this loop, meaning I can reset the previous value somewhere around here. So I can create a attribute point group wrangle for the mover. Or probably I don't really need to reset the previous, not sure, maybe not. Let's try not to do it and see if it still work. Okay, let's go back again and see if the point can move correctly or not. Okay, let's see. I'm gonna make this slower. Okay, now I think it's moving correctly, and I see one problem here. You can see that right here, crushing. Okay, that's not good, is it? But other than that, it looks great. It's not really trying to go to the same position at the same time. So I think I'm missing one additional conditions. Try to avoid this intersection crossover. Okay, so I do need to search for the conditions, what kind of condition I need to think of. Okay, so let's say we are starting at this point, and I need to say that the point, even though the point has moved to the other direction, this point cannot go to where the point has already been there. So I thought I did that, but I think it's missing. And that value is probably the previous value, so I might still need to reset it. Let's see if I set the value, I can fix this. So for the mover point, I'm going to set the previous value to -1 and see it still works. Okay, now it was at the frame 100, somewhere on here, so let's reset the solver and see if you still see the same thing. So going back to the 100, okay, you still see the same thing, so I guess I need to create the conditions for this one. So let's see, this should be written right here, and probably related to the previous information right here as well, which I thought I did, but it didn't really work out well, did it? Okay, let me see if the previous point has been set correctly first of all. Going back to this mover. Maybe I can check somewhere on here. Okay, somewhere on here, and check this one. I'm going to activate this one and see if the previous value has been updated correctly for the specific point. Now in this case, let's say 95. 0.95 is the mover point, and currently the current number is 67, coming from this point going into the A58, which is, I guess, this point. It's a bit hard to see because I do see the caches right here, but I think it should be correct. This is 58. Now what's the previous one? 67. Okay, and as soon as it comes right here, okay, I guess I need to go back to the loop to have a bit more iterations. Okay, somewhere around here. Okay, why am I seeing these caches? Okay, going back. So previous one became, so at this moment the previous value was 58, so that's correct. Now going back a little bit, becomes okay. So as soon as it becomes 101, this code will run, this node will run and choose the next candidates, and the thing is that I don't want to choose this one right here. And at this moment, somewhere on here, I need to see what kind of conditions I need to care about. So currently, so for the 95, the previous number is 67, still at 67. Though I actually want to change this, but at this moment the current number has not been changed yet, I guess. Okay. So the current number only changes after it becomes 101, which is this one right here. Okay, so the timing is a bit off by 1 frame, so that's kind of a problem. Wait a minute, current value is being chosen right here. I see. It's a bit tricky. Okay. So in that case, I actually don't want to move to the current point as well. Not previous, but also the current as well. So I'm going to pick the current from the point. And also remove that value from the candidates. And what else? And I would also want to check the group number for those points. So going back to somewhere around here, check the group. So this is 58. So 58. I have this go group, next agent group, and agent group. Okay. So I don't want to move to those. The next agent is okay, but I don't want to actually go to where the other agent is already being used. So I guess that's the condition I need to use. The thing is, I did remove the previous agent right here. So, okay, so that's kind of a bummer. Probably I would like to create another agent like the previous agent as an information. Okay, yeah, that might be the value that I need. So let's create that. Going to create point wrangle. Before deleting the agent, I am going to transfer from agent to the previous agent. So set point group prev agent. Now it's getting more complex than I thought, but it's fun creating those logics. And then I can also remove the group called previous agent somewhere around here. Prev, not this one. Deleting the prev agent. Okay, set point group prev agent. All right. Now I can go back to the next agent and I can create the conditions right here. If endpoint group 0 prev agent at neighbor is equal to 0. Okay, I think this should work. Doesn't it? Alright, let's see. Let's see. Okay. Reset it. Okay. I don't want to see these caches. Let me reopen this to delete the cache. Okay. Now let's check this out. If I play it and it was around 100 frames, and yeah, I think I have just solved it. You no longer have this like collision. Oh, wait a minute. I still have it. Okay, didn't really solve it after all. Why is that? Okay, going this way and okay, I think I'm missing something. I guess I'm missing something here. Let me check. So, checking the point number 57. Point number 57. What's this group? Do I have this previous group, previous agent? So I have this previous agent 0. Why does that? Wait a minute. So 57. Okay, so 57 has been chosen as the next agent. That's correct. As soon as it becomes, oh wait a minute, and this becomes current agent. Okay, so to avoid these points going to the other side, I also need to check if the point is the current agent. I thought I did do that. Yeah, this is the wait a minute. Okay, I shouldn't use AND, but instead I should use OR. That's the reason. Then in that case, I might not need to have this previous agent filter after all. Let's check. Okay, a lot of tweaking here. Hopefully this works. Wait a minute, didn't really do that. Didn't really work. So let me also add this another filter. Wait a minute, this is yeah, it still is okay with the AND. Yeah, it's still okay with the AND filter. There's nothing wrong with these. Okay, getting stuck. Alright, what else? What else that I am missing here? If I set this candidate to more than 1, does it help? Nope. Nope. Okay. Okay, it's actually not working. Yes. Okay, so this is obviously wrong, so let's check this out from the first frame. So let's go back. I'd like to fix this out. And let's start from the first iteration, first feedback iterations. Okay, so these yellow points is the first candidate, and Okay, so this is initially wrong. Why is it choosing this point as a moving point? Now that's obviously so wrong. Alright, let's see. Let me see why. Right. First of all, let me check the numbers. So 76, 77, 78. 0.78. What does it look like? 0.78. So it is agent, yeah. So if its agent is equal to 1, then it should not be chosen as a candidate anymore. But it actually has been chosen somehow. And that's the question. Why? I think I'm missing, I think I did something wrong somewhere. So I have these conditions. First I'm checking the neighbors. Checking all the neighbors in point group, agent. Neighbor is either agent or a next agent. And if not, if both of them is not included inside this group, then I am adding to the candidate. Now let me have this candidate as an array stored into an attribute to check. Okay, so for the 0.95, is it? Current go. Is it the point? Not 0.95, but 0.77, I think. So let's see. So 0.77. I have just applied. I have just attached. Wait a minute. Okay. It says 0.78. This one. How's that? Okay, let me see which point has just been chosen. Let me go back to the 0. Okay, this one. Fine, go. Okay, at this moment, this seems like wrong because both of them are chosen as a first candidate. That seems wrong. So I guess these ones, I have something wrong with these ones. So let's see what's wrong here. What's wrong with these one? So I am checking the agent, which are those 2 points, I think. Right, and I'm getting the neighbors, and I am checking whether it's inside the agent and the go 1 is equal to 0. It's not, return. And I'm currently in the go. Well, okay. Probably I need to current go. Okay, that's better. Okay, so actually this was okay. Now going back to the initial conditions. So this is the, is this the initial one? Let me just delete these so that, okay, so I think this is not the first point, but this is the second set of the point has been chosen. Somehow it's looping. going to see a single pass. Okay. Still. Well, let's look at this current go. Although if I increase this number, it doesn't really increment, does it? Okay, I'm going to color this a bit different. I'm also color the go value, go group with blue. To do the debugging, so the blue has already been chosen, but when exactly? I might need to remove the stop conditions for a while. Let's remove this one. Or I'm just seeing the caches. Probably that's it. Alright. Okay, so seems great. Seems to work fine. I'm going to check whether which direction this point has chosen as a next candidate. So for these points, after I have chosen next agent, I am going to color the next agent with green, and obviously this has been chosen, so that's totally wrong. That's the problem. So 0.77, going back, this one, the candidate has been chosen as 68, which is this one, 76 this one, and 78 this one. And somehow this one has been chosen, which is set as an agent. Should not happened. So the condition must be wrong somewhere around here. Okay, let's check this out. So from point to point. Now, start from the beginning. I have retrieved the neighbors. Let's check everything is correct. Okay, and I have created the empty candidates, which is fine. I'm looping through all the neighbors, getting the neighbor point number, and at each shoot, spell mistake. That's probably it. Some stupid mistake I made. Yup. Alright, now the candidate became left side. Alright, that should be it. And I no longer need these, and I can go back to this one to add the condition back to stop the for each loop. Now let's go back and see if things going to work. Why does this point move to this right here? Okay, something weird happened, which is obviously wrong, looks wrong. Alright, what is that? What is that? Okay. What is the current t value? If its t value is... maybe the current number is wrong for this point, 96. 96. Current point number is, what is it? 78. Looks correct. Next point number is 0. That's wrong. Yeah. Okay. This is wrong. And going back, the next point, the value that I have been setting next is right here, meaning something must be wrong here, right? Okay, let's see why. Let's see why. The value has been chosen as 0, meaning this point haven't used, even if it didn't find any place to move. Let me try to remove this conditions to see if it's going to work. Yup, it worked, so obviously this is wrong. And I guess I shouldn't delete this candidates, the previous number from the candidates, I think, which would remove your own number, is it? This means is that you don't want to go to the previously assigned position, which still should work, but by making the conditions more than 1. Let's see what still has some problem here. Okay. Moving the point, getting the previous. Let's just remove it and see if it still works. Nope. Reset. Nope. Still has some problem here. Huh. Why is that? Okay, I think I just removed something. And what if I move this? Okay, obviously that's wrong. If I don't change the candidate, which means it stops at its current point positions, but it's not happening like that, so obviously something is wrong. Something must be wrong. The next number has been applied as a wrong value. So I'm going to check the mover group. All these mover group. I'm going to check all the next number. Okay, so some of the value has 0, so those are the one which is wrong, which should be having some problem here. Okay, so one is 96. Huh. But this moment and this moment this moment looks okay. This one has 78. This one current. Why those values are not being updated? Huh. Meaning, okay, I know the problem. I have to increase this loop because after I have picked the first candidate, I didn't like loop through all the possibilities, I have to raise this number up so that all the points should have its candidate. Okay, so that was the problem, and now that was the problem, I think I can enable these conditions after all. Okay. Finger crossed and... Okay, I still have some problem. Okay, why is that? This is so tricky. Why? But feedback loop just stopped at 1, so something must be wrong here. Detail, stop, can go num. Let me check the detail value. So it shouldn't stop. This condition is not met, but kind of actually stop at feedback loop 1. Single pass. Uncheck it. Alright. Okay. Please blow. What is happening here? Huh. Okay. Another thing I was fixing the candidate number. I think I have to enable this one. Okay. Alright. Is it going? Is it? Did it jump? Oh yeah, it's from the first frame, so that's fine. Okay. So whenever it is blocked by other agent, it stops. Okay. Looks good. Finally. Finally. Alright. What are these points? I'm not sure. Okay, that was just a cache, I guess. Okay, so looks good. Moving great. And if I color it based on the variant, ramp from attribute, variant, I can either make it yellow or red based on the type of the agent. Yellow should be a Pac-Man, red is going to be a ghost. Okay. Alright. Now, I think it's working. Now I'm going to try this out with the three-dimensional geometry. Okay, it's taking a lot of time here, but I'm not sure how many people are still listening, but it's just for my fun, so guess it's okay. Alright, so let me try with these and see if this could work as well. With these triangle grid. Let's reset it. Interesting. From the triangle, the path became like suckable. And yeah, seems to work just fine. Alright, this could be interesting. Alright, now I can see that it's working, and I can also visualize the normal direction. Looking great. Now now that I have the base, what I need to do now is to just create some simple modeling by using this point position. And let's make this quick. Let's start from the plane. First of all, I am going to create the base plane by doing some extrusions. as a simple base. So let's bring this, let's connect this to the null node. Let's name this base, and going back, going down, going to refer to that object. Okay, and by doing some simple extrusions, I'm going to do the poly extrude. To do the extrusion per or just create the thickness. Or maybe I can stop by in setting for each element and only use the front, create like a tile, no, make it like 0.03 or something. Doesn't really matter about the numbers, it's not really important here. And then offset this backward or to the negative direction to have a little bit of thickness with the side and the back. Then let's make this reversed. Okay, and this is the base. I'm going to color this maybe set it as white for now. Okay, so let's also create a Pac-Man itself from a sphere, which is going to be really simple. I'm going to make it really simple from a sphere. I'm going to make it as a polygon. Let's say frequency of 3 or something, right? And I'm just going to do the Boolean, which is a kind of a brute force modeling, but doesn't really matter. Circle, let's make a circle, and let's make this YZ plane, then make this 0.01 as a radius, make it a polygon, and I want to make it as an open arc. Where is it? Maybe make the radius a bit larger, and to make it as a, okay, let's make it as a closed arc, and from 60 degrees to 120 degrees. Okay, and I'm going to do just simple Boolean. First of all, extruding this surface by, I don't know, 2 or 3, having the back side, and then move back, transfer back, by 1.5, oops, then do the Boolean. Okay, so this is going to be the base, and let's see if this can be placed on top of this moving or agent position. Now I guess the radius of this Pac-Man is a bit too large, so make this radius 0.5. Alright, now let's also set the color to yellow, or maybe the color will be controlled by the copy to point, so let's keep that. I'm going to use the copy 2 points, then to the mover point, I'm going to, not this one, copy the Pac-Man only to the mover point. So I'm gonna set it to mover, and based on the variant I want to change the type of the shape. So enable this piece attribute. To use this, I think I need to create the attribute point attribute to this primitive, or add points. So attribute create, and set the variant to 0 for the Pac-Man. Variant integer to 0. Okay, now I have these Pac-Man facing to the same direction. In order to make this facing randomly, maybe based on the direction where the point is moving, I need to set the up vector. Okay, now let's do the ghost. I'm gonna make it simple as well, starting with the same sphere. I am going to create the kind of a hollowed, I don't know, wave on the bottom, on the leg. Alright, so point wrangle. So previously the Pac-Man was facing upward like these. So same as these. For the ghost, I'm going to create the leg like these, right here, or maybe right here. I don't know which direction. Okay, to do that, let's name this ghost. I'm gonna use the point wrangle to use some trigonometry, like sine wave, to create the wavy like leg. So if at point dot z, which is this direction, is more than or less than 0, then move the z value to a minus 0.5. Okay, so like these. Maybe you don't have enough points to create the wavy leg, so I'm going to increase the frequency a little bit. Like this. Maybe a little bit more. Right. Might be too heavy, but let's go. Let's try with these. Now, after setting the point position halfway to the bottom of the, which is at this floor, I'm going to set it as a wavy pattern by introducing some sine wave. So for to use that, I'm going to have to create an angle for the wave, and I want to change the angle based on the position of this circle. Okay, and the position of the circle can be determined by the angle of this circle based on the, I don't know, x-axis or something. So to get that angle value, I can use a function like a10to based on the at py at p dot x. That should be the angle, and I can increase the angle by multiplying with some the multiplication of 2, so that you have a continuous wave. It's multiplied by 2 by some integer but number. Okay, now I have just created the angle value. I can now convert this into a height value to move the point using the sine. multiplied by an actual height. And probably I could multiply this by height plus 1, so that the range becomes from 0 to 2 in this case, and multiplied by height will give you a value in between 0 to 2 multiplied by height. Okay, let's set the height to 0.1. And now finally I'm going to update the z value with this height, add or increment the height value. Let's see what happens. Not bad. I mean, the center area looks a bit too busy, but if you look from the side, not bad. Okay, it's not bad. Alright, so let's also set this variant. I at variant is equal to 1. Now I'm going to merge it with the Pac-Man shape. See what happens with the copy to point. Okay. Now starting to look like what I want, but it obviously is not that interesting because first of all, the Pac-Man is not facing toward the movement. Ghost is not really moving at all. It just looks like sliding, so let's also fix that. Since I am using the copy to point node by introducing one more directional value, which is a up vector, I'll be able to control the side rotation. So let's do that. Going back to the solver, I need to update the mover point with this up vector. Now I can go back to the initial mover value right here, where I can set the initial a up vector, which could be random for now. So currently the normal direction is up vector. I mean the normal direction is facing upward, meaning y direction. So I want to make the perpendicular direction to that. In this case, by referring to the neighbor point might be a good idea. So for each point where I have created the mover, I am going to get the first neighbor point using the neighbor at pt num 0, and then get the direction to this neighbor point. Get the direction and pause minus current point position, and normalize this one. Then set it as up, initial up vector. Okay, oops, what happened? Huh. What is this? Huh. Okay, something new had happened. Okay, and I cannot seem to move my mouse anymore. Let me reopen. Okay, somehow I cannot really touch my Houdini anymore. I think I need to quit Houdini and reopen it. Let me do that. Save and quit. I don't know what has just happened. What is my machine spec? Well, currently I am working with the Macintosh. I have just bought a Mac Mini, which is running with the M1 processor. It runs okay, I think. I don't do the renderings in this machine, so if you are just doing the modeling, I think it's just fine. When I do the modeling, I am using the Windows machine, obviously. The spec is RTX 3080 together with the Ryzen Threadripper and 32 core. Yeah. Which is pretty fast. Okay, where was I? It is really rare to crash. Seems like, so yeah, I found that as well. In Macintosh it crashes pretty often. That's a bummer, isn't it? Or it's just my case, I don't know. Where was I? What was I trying to do? Oh yeah, I was updating the normal direction. Okay, and I also need to update this up vector inside here, where I was updating the normal. Aside to that, I also want to update the up vector, and that is the actual direction where the point is moving to, which is this direction, npos minus cpos. So let's create that direction vector. Vector direction is npos minus cpos. Normalize. And I don't want to just like turn the I don't want to just like rotate the Pac-Man or Ghost instantly, but I do want to have a little bit of like lerp or the feeling of the animation interpolation going from one direction to the other direction. So to do that, I am going to update the up vector by using the lerp, going from the current up vector to the new direction by some, let's say, 0.1, which will slowly rotate the Pac-Man direction to the new direction using several frames. Let's see what happens then. Now you can see that the Pac-Man is facing at each different direction, and if I play it, I can see that it's rotate like a go-kart or something, like a car. Maybe too slow. Yeah, let me fasten this a little bit. I'm going to increase the lerp value a little bit, like by 2.2. Might be a better value. Let's check this out. Okay. Where did the grid go? Okay, if I play it, okay, looks good. Now, since this is a Pac-Man, I want to open and close these mouses. So to do that, I'm just going to procedurally animate the opening, which is this angle right here, based on the frame value, and maybe together with some sine function again. So going back to this one, I'm going to define the base angle for the opening. Let's see. Pac-Man mouth angle, which is really not an important parameter at all. just for fun. Let's make the maximum 90 and start with 30. Okay, copy this one. Going back to this one right here, and since the 90 degrees is when the mouse being closed, when both of the value becomes 90, the mouse just closed. So make this as a default value, and for the minimum value I'm going to do the subtraction. For the maximum I'm going to do the addition. Now paste the angle, the base angle, multiply by the sine function. Sine based on the frame, multiply by, I don't know, some speed, and remap it in between 0 to 1. Okay, and I'm gonna copy this one to the next one and change the operator to plus. Now if I play it, now I'll be able to see the mouse moving like I want it to have. Alright, looks good. Now for the ghost, it just looks like sliding, so I'm going to also create some simple animation, like looks like wiggling, maybe rotating. If you look from the top, rotating back and forth, these like a wave. So let's also do that. I'm going to create a new transform node somewhere around here for the ghost. And do the rotation at z-axis in this case. So let's say 30 multiplied by sine of frame multiplied by 30. So you'll be able to have a minus 30 to 30 degree rotational angle. And let's see what happens. Okay, looks weird, but okay. If you want to set an eye to these ghosts, you can also do that, I guess, by creating adding some sphere. But I'm just gonna ignore this. I'm just gonna go with these for now. Okay, making ghost all red might be too boring, so going back to the color, I'm going to let's see. I want the ghost to have a different color, so going back to the initial value right here where I have created the ghost. Where was it? This one, init mover. So this is when the value was ghost. So for these ones, I want to set some random values to each of the ghosts to define the characteristic. So let's say set point attrib 0 call pt, and I'm going to create a random value based on the point position plus some seed plus some additional value, and fit it, remap it in between 0.5 and 1.0. Okay, for the Pac-Man, I'm just going to set the color as 0. Set point group, set point attrib 0 call pt 0 0, since I want to make it float. Alright, going back, color, instead of the variant I'm going to use the call. And what's wrong? Oops, something has to be wrong. Okay, now going back to the color node, let's set the middle to orange then set these to other colors that I will use as a variant. So only the ghost will be affected by these colors, and Pac-Man always remains yellow because it's always 0. Okay, starting to get cute. Okay, looking good. Now let's also raise this whole character, move up a little bit to the normal direction. I'm just going to do it right after I have set the color by adding to the normal direction by, in this case, 0.5. Maybe I should have parameterized this as well, but for now I think it's fine. Okay, now connecting with the floor, I have just created, let's make this floor color to some darker color. Maybe white, it's fine. Okay, I think it's working fine, just fine. Now I think it's moving fine, so let me try these out with three-dimensional geometry to see if it could still work. So even with these triangle grid, it's still working. There's too many ghosts. Let's reduce the number of whole characters to 10%. Okay, now there's only one Pac-Man. If I want to increase that, I can then make it 40%. Okay, still moving great, and it shouldn't touch with anything. And as a additional stuff, like if you want to create like a bait like you see in the game, you can just get the center point of the floor, which is these one, and add a center point and move it upward. I am not going to create an interaction between the bait and the Pac-Man, which going to take a bit more time to do, so just gonna create a static bait. Or does it call bait? I'm not sure. And these should be running with the primitive, and pt is equal to at 0.0 p plus a normal direction multiplied by 0.5. Okay, and let's set point group 0 bait pt with 1. Alright, I'm gonna copy some sphere, some low poly sphere to those points. Copy 2 points to the bait. Now that's obviously too big. Okay. And these one, I'm going to set it as white color. So instead, this one, I'm going to make it a bit darker color. Alright, now let's make the background a little bit lighter. Okay, set all the material color to be a bit brighter as well. And finally, I think this is what I wanted to see. Now, yeah, I think it's working fine, just fine. And the good thing about this process or this method is that this can be run on any chosen geometry, I think. So it could even run on top of the pig head if you want. Set the scale of the pig head so that it can be aligned. I'm going to scale this up a little bit. Somewhere around here, somewhere around like this. Now obviously there are so many like primitives, so I think might take a little bit of time to calculate all the available positions for the next go. So let's reduce the number of ghosts. Going back to this one, set it to 0.25. 0.2. And let me also give a little bit of space. It doesn't really change, does it? Nope, didn't really change. I guess because there are some really small planes out here. And obviously the ball is a bit too big. Okay. And it's a bit too slow. If you want to make it faster, I think you can just pack these shapes individually. Like these. To do that, I need to set the variant. This one. And I could also pack this geometry as well. And I think this will speed up a little bit. Not that much. Okay. This geometry is not that interesting. Make it really simple might be much better. Okay, so that's pretty much it. Thank you for those who have spent a long time with me listening or watching. I'm not sure if it makes sense to you by following these steps. I hope it did. And I hope you find it somehow interesting. I'm going to try to make a bit more simpler stuff for the next week. Okay, so if you have any questions, please let me know. If not, I am going to end this live. And I will prepare the video so that how I managed to send the setup to a Unreal Engine 5 with the attribute. Maybe I can show that right now a little bit. And I'm gonna explain the exact process how I did that, explaining from scratch. Okay, so let me see where I have done it. Where did I do that? Okay, so this is... Okay, so I'm connecting to a Unreal 5 remotely. Okay, there is a bit of weird things happening. I think I have replaced some textures or something for the vertex animations and causing this irregular animation, which is obviously not what I wanted to have, but I'm gonna show you how exactly you can send the Houdini animation to the Unreal Engine 5 so that this is the correct one. So what I'm sending here is the additional attribute to use it is for the emission right here. And that's the, and this movement is using the same logic as this Pac-Man that I've created. So if you're interested, if you have followed Pac-Man, then you'll be able to create this rotating box easily as well. Okay. Well, that's another topic. To send the attribute from the Houdini to UE5, simply, basically I'm using the VAT with the custom, like some tweaking, because originally it doesn't allow you to bring any additional one. So I'm going to show you how you can bring out the additional attribute by yourself as additional informations to render inside Unreal for real time, which could be useful, I think, which makes you do similar stuff you do in Redshift based on the attribute. Okay, so that's pretty much it, and I would like to end the tutorial, the live stream here. Okay, so thank you very much for all the comments. If you're interested in this kind of tutorial, please also join next week at the same time as well. I'll be appreciated. And I am going to upload the file that I've created today to the GitHub, and you can download it from the video description page as always. So if you're interested in this kind of things, please download it and check how it works. Okay, I'm also doing the Patreon myself, so if you are kind enough to support me, that'd also be great. You can also go to the page from the video description page of this YouTube video. Okay, that's it. Thank you very much, and hope to see you next week. Good night.